Hi, I'm Mr. Rutherford. In this problem, we're going to be looking at a real-world example. Entertainment. An amusement park currently sells an average of 650 all-day ride passes per day. The price of each pass is $12. The owner would like to increase the price of each pass and has hired a research company to help her determine the effect of a price increase. The research company determined that for each $1.50 increase in the price, 50 fewer people will buy passes for the park. A. How much should the passes cost in order to maximize the income for the amusement park? So in this problem, we need to determine how many times the owner of the amusement park should increase the price of the passes by $1.50 to maximize the income for her amusement park. So first, we're going to let X equal the number of price increases of $1.50. We're going to let 12 plus 150 multiplied by X, and that will be equal to the price per ticket. Because the original price was 12, and we're adding $1.50 with each price increase. And then finally, we will have 650 minus 50x. That will equal the total number of tickets sold. Now, in order to find out how much income the amusement park has made, we need to multiply the number of tickets by the price per ticket. So we're going to write this as a function. So our income will be function I of x, and that will be equal to the number of tickets, which we said was 650 minus 50x. So 650 minus 50x multiplied by our price per ticket, which is 12 plus 150 or 1.50x. Now we're going to go ahead and simplify this. So we will have 650 times 12 plus 650 times 1.50x plus, well, let's go ahead and put that as a minus since we have a negative 50x. So minus 50x times 12 minus 50x times 1.50x. Okay, so let's simplify this. So now we will have 7,800 plus 975x minus 600x minus 75x squared. Now we need to go ahead and combine like terms. So this will simplify to 7,800 plus 375x minus 75x squared. Now let's go ahead and rewrite this in ax squared plus bx plus c form. So this will be equal to negative 75x squared plus 375x plus 7,000 $800. Now if you notice, this is our function I of x. I of x is a quadratic function, and so we have terms a, b, and c here. Our a equals negative 75, b equals 375, and c equals 7,800. Now, what we need to determine is how many times, again, she can increase the price by $1.50. So, we need to then go ahead and find the x-coordinate of the vertex of this quadratic function. So, if you recall, the formula to do that is x equals negative b divided by 2a. So let's substitute these values of a and b into that formula. So x equals negative 375 divided by 2 times negative 75. This will simplify to negative 375 over negative 150, and that will be a positive 2.5. So in other words, in order to maximize the income for the amusement park, the owner needs to increase the price of the ticket by $1.50 2.5 times. So we need to substitute this value 2.5 into our formula to find out what the price per ticket is going to cost. Remember, we said that was the price per ticket was 12 plus 1.50 times x. So if we substitute 2.5 into this, we will have 12 plus 1.50 times 2.5, which will equal, that will equal $15.75 per ticket for her to maximize the income for the amusement park. B. What is the maximum income the amusement park owner can expect to make? Well, we found in Part A that our X, which was the number of times that the owner would increase the price, equaled 2.5. So we're going to need to substitute that into our function. Our function, I of x, equals negative 75 x squared plus 375 x plus 7,800. So we're going to substitute 2.5 in for x in the function. So negative 75 times 2.5 squared plus 375 times 2.5 plus 7,800. Go ahead and use your calculator on this one, and this will simplify to 8,268.75. So in other words, the maximum income the amusement park owner can expect to make in increasing her ticket price 2.5 times will be $8,268.75.